This video is brought to you by Squarespace. Hi guys, welcome to Amateur Chemistry. So in today's video I am going to be tearing down a car battery to extract sulfuric acid from it and then distill it to concentrate and purify it, as well as perform some really interesting experiments with it. Okay, so as you may know, sulfuric acid is a very important and useful chemical. I would even consider calling it the most useful chemical, because it finds use in thousands of reactions as a reagent or a catalyst, and our modern civilization just couldn't exist without it. I myself have used it in most of my videos, and I felt that it is finally time to dedicate a separate video to it, because not only is it insanely useful, but also pretty hard to get. Due to being very dangerous, it is not just something that you can buy in any random store, and even if you manage to find it as, for example, drain cleaner, it is often diluted and contaminated with a lot of random junk, and in this form it isn't all that useful. Most reactions involving it require it to be somewhat pure and often concentrated, and the dilute stuff that you can find in drain cleaner just isn't going to cut it, so today I'm going to show you how it can be purified and concentrated, but first I have to find a source of it. You see, sulfuric acid, due to itself being very reactive, is hard to create by an accessible chemical reaction in a reasonable quantity, and the most viable option for getting it boils down to extracting it from an over-the-counter product. As I said, it can be recovered from some professional drain cleaners, but they are not sold everywhere. Fortunately, there exists a source of it that is available almost anywhere, while being decently pure and concentrated, and that is a car battery. It all comes down to how batteries work, because each conventional battery requires something called an electrolyte, which is the carrier of electrical charge, and it just so happens that in most car batteries, this electrolyte is 37% sulfuric acid. This means that if I got a car battery and extracted the electrolyte from it, I could then purify it to obtain my precious sulfuric acid, and I actually have one that I randomly found in the back of my garage, and it will be just perfect for this. However, before I start doing anything, I have to thank the sponsor of today's video, Squarespace. Squarespace is an all-in-one advanced website creation platform specifically designed to make entrepreneurs stand out and succeed online. Squarespace allows you to create incredible websites with ease, whether you're just starting out or managing a growing brand, and use them to sell anything from various products to your time or engage with your audience. Squarespace offers amazing features like their powerful Fluid engine, which allows you to really unleash your creativity and make your dream website idea come true using their best-in-class website templates and easy-to-use interface. Squarespace also provides you with the ability to connect dozens of extensions to your site to extend its functionality, or their useful analytics tools designed to help you discover many important details about your business. For a free trial, check out squarespace.com, and when you're ready to launch, go to squarespace.com/amateurchemistry to save 10% of your first purchase of a website or domain. Anyway, the battery that I ended up finding turns out to be in quite a good shape, and it doesn't look like it's been used before. It is also pretty small, and the larger ones are much more common, but as long as it's a lead-acid battery, it should work for the extraction. Other types of car batteries often don't contain any sulfuric acid, so I had to make sure that this is a classic lead-acid electrolyte battery. Except for the sulfuric acid, it also contains plates made out of lead and lead dioxide, which makes this whole thing very good at storing energy, but I won't get into much detail on how a battery works here, and all that matters is that it has the sulfuric acid I need. Also, one important thing to do before starting the extraction is to measure the battery's voltage, because when it runs out of charge, most of the sulfuric acid just turns into water, so to get all of the juice out of the battery, it has to be fully charged. Fortunately, my one is, because it's still quite new. Before starting the extraction, I also wanted to wait to later see how much acid I managed to get, so I got it onto this random food scale that I found, and it currently weighs 10.5 kilograms. Okay, now to finally begin extracting sulfuric acid, I removed the label from the battery, revealing these 6 plastic screws which close the 6 cells of the battery. I unscrewed them and started pouring the electrolyte out into the steel pot. It was really satisfying seeing this liquid gold flow out of the battery, and there was much more of this stuff than I anticipated, so to get more space in the pot, I drained some of the electrolyte into a beaker, which resulted in a pretty large splash. Fortunately, I was prepared for something like this to happen, and quickly got everything under control. In the end, I was left with 2 full beakers of some really cloudy electrolyte containing a lot of stray lead which I will have to remove, but before that I wanted to take a look at the now empty battery which has lost almost 3 kilos of weight. I wanted to tear it apart to show you its insides, which turned out to be way easier said than done, and after struggling with this thing for like 3 hours straight, I managed to open it up. As I said, it is composed of 6 cells with some lead and lead dioxide plates in them. I actually plan to recover the lead and do some experiments with it in the future, but now it is time to take care of the electrolyte. To get rid of the insoluble lead, I quickly filtered everything using a cotton filter, leaving me with some nice and clear electrolyte along with some grey lead dust. The electrolyte still contains trace amounts of lead dissolved into it. It is also not too concentrated, and I can check that by measuring its density and using this handy dandy online concentration chart. It is now only about 35%, which makes it good for some reactions, but for the majority, it has to be more concentrated. When it comes to concentrating it, there are 2 main options. The first one involves just boiling it down on a stove, which is incredibly quick and simple, but it produces a ton of incredibly nasty fumes, which makes this method viable only outside or in a powerful fume hood. Also, the thought of having some hot concentrated sulfuric acid just boiling in the open like that kinda scares me. That's because while cold and dilute, sulfuric acid is not too dangerous and I can even touch it with my finger without feeling anything. Hot concentrated sulfuric acid on the other hand is by far the angriest chemical I have ever worked with, and just a drop of it could burn a hole in your skin in seconds. Anyway, when the sulfuric acid finished boiling, I let it cool down. Despite being concentrated, it is disgustingly yellow and contaminated with some lead. So while this method is quick and easy, I will now show you the real method on how to obtain some pure sulfuric acid. It involves distilling it, which leaves all of the impurities behind and results in pure 98% sulfuric acid. It actually can't get to 100% because it forms something called an azeotrope with water, preventing it from getting more concentrated, but 98% is more than enough for pretty much every application. This method, however, has a slight drawback because sulfuric acid boils at a whopping 337 degrees Celsius, which means that a good heating element has to be used, as well as the setup has to be robust and not hacked together from some junk, because you have to treat hot concentrated sulfuric acid with respect. Fortunately, I have a heating mantle that can reach high temperatures, as well as enough glassware for a proper distillation, and to start, I first have to get some boiling chips. You see, sulfuric acid on its own has a tendency to boil very inconsistently in big bursts, which is incredibly dangerous, so to mitigate that, some boiling chips have to be used which allow for even boiling. They can of course be brought from a supplier, but there is no fun in that, so I decided to make my own from this broken beaker which I ground in a mortar and added to a flask. I also added some old and demagnetized Teflon coated stir bars because after doing this procedure many times, I found out that they also help with the boiling. As the last thing, I wanted to add some sand for good measure, so I stole some from this random sand pile in the middle of nowhere and washed it with some hydrochloric acid to clean it up just like in the silicon dioxide video. I then added it to the flask, followed by about 700 ml of the filtered electrolyte. I didn't measure the exact amount of it here and went with a good rule of thumb, which is to always fill flasks only to about half their max volume to prevent any accidents. I then assembled a simple distillation apparatus and greased the joints with some concentrated sulfuric acid, which is pretty much the only thing that can withstand this harsh distillation. And I know that this is a bit counterintuitive, but you can get this starter amount of acid using the method I showed earlier. I also used just an air pump for cooling here because using water would result in such a large difference in temperature that the glass might crack. Anyway, when everything was ready, I covered the flask in aluminum foil to insulate it and started heating it. After about an hour, some water started coming over. It had a neutral pH which will increase as time goes on because some of the acid goes over along with it, which makes this process not perfectly efficient. While this is cooking, let me tell you about a chemistry supply shop that provides me with many chemicals, BM Chemistry. BM Chemistry sells a lot of hard to get reagents along with laboratory equipment and lots of other things, so you can check out their page, to which there is a link in the description. Anyway, for a few hours, mainly water came over, and when the volume of the electrolyte decreased sufficiently, I swapped the flask for a smaller one. As you can see, the acid is now really yellow for some reason, and I continued to distill it for a few more hours. As time went on, the distillate got more and more acidic and some scary looking vapors appeared in the apparatus, and to know when I would start collecting the sufficiently concentrated stuff, I often checked the distillate with a piece of paper to see if it was getting dissolved. This is because only very concentrated sulfuric acid has the ability to eat through organic stuff like paper or sugar, and when the paper started getting consumed, I started collecting my product in the small flask. After about 6 hours, the acid stopped coming over, so I stopped the heating and got my product. I also disassembled the apparatus, leaving me with some weirdly white and cloudy lead sludge. Also, before checking my acid's concentration, I had to process the rest of the electrolytes, so I just repeated the whole distillation process 4 times, which took more than forever and left me with a ton of some nice and for some reason ever so slightly yellow sulfuric acid. In the end, I managed to make slightly over 850 grams of it, which is really cool. I can't precisely measure the yield, but I would guess that it is something like 80% based off the electrolyte. I also measured the acid's concentration and it came out to be almost exactly 98%, which is insanely cool, and I am really surprised by how well this whole thing turned out. Okay, and now when it comes to the properties of this acid, it is a pretty viscous liquid that heats up very much when diluted with water, and that's why you should always add it to the water and not the other way around like you see here. It is also of course very acidic, and what's funny is that it can't just eat the pH paper because it also just so happens to be a dehydrating acid, pulling water from many organic things like paper and sugar, leaving behind pure carbon structures and giving off a lot of heat in the process. As you can see, it gets much angrier when concentrated, while hot it is also an oxidizing acid, being able to slowly dissolve precious metals like copper, and as I said in the beginning, it's just incredibly useful and I would definitely use it in a lot of future videos. Anyways, I hope that you guys enjoyed this short project and you can consider leaving a like or subscribing to my channel. You can also join my Patreon where I post a lot of extra content. Also, as always, big thanks go to all my Patreons. Thank you very much for all your support and making projects like this possible, and see everyone in the next video.